Hi, and welcome to Ellen High School's discussion of electrochemistry at the AP/IB/HL level. We're talking about whether or not cells or redox reactions as written are spontaneous or non-spontaneous. We finished up our discussion talking about E0. Now, E0, we've defined it a little bit, but I want to give you a little bit more detail. When we get E0 of a cell, what we're talking about is the minimum voltage that must be supplied if it's non-spontaneous. That's for a non-spontaneous because we have to put in a power supply. Or if it's spontaneous, it's referencing the maximum voltage available to do work. And that would be a spontaneous situation. And you're going to be exploring these online in class. Now, let's link this now to delta G. Delta G naught, the math equation for that is that delta G naught, remember we're talking about standard ambient temperature and pressure, is negative N, this usually written as a very fancy F, E naught. So let me define these terms. N represents the number of electrons in the balanced exchange. So that's where we're going to get that multiplication factor that we neglected, that we skip when you calculate E0. In our reaction, ours was 6. Remember, we had to balance it so that we both gained and lost 6 electrons. E0, we know, is our minimum or maximum voltage. Let's talk about F. It's a very, very important constant. F is our bridge, what I call our bridge, between the world of chemistry and the world of electricity, or really getting into physics a bit. Not that I have the ability to get into physics too much, but getting into that world of amps and voltage and power that you talk about in physics. We're going to use this in dimensional analysis. F is Faraday's constant. When I was in undergrad, that was the name of our science hall. It was Faraday. So it's called Faraday's constant. And it is roughly 96, I think it's 96,495, but we can usually get away with 96,500 coulombs, which is a measure of charge, for every equal to or for every 1 mole of electrons. It's a unit equality, so 1 mole of electrons that are transferred. Very, very important constant. So all we have to do is plug into that and we get our delta G naught. So for our reaction that we designed way back in about 5 videos ago, we have minus 6 times 96,000, and then a minus 0.61 volts. And when we do that mathematics, we're going to get a positive 353,190 joules. So you've got to have delta G in joules to use this equation, which would be the equivalent of plus 353 kilojoules, which you now know is a non-spontaneous situation. That says nothing about rate. It just means we have some significant thermodynamic barriers that must be overcome in order for this reaction to proceed to form product. So those are our 3 ways, and you may see them as multiple choice or free response, but you definitely need to know all 3 of these ways for determining whether or not a redox reaction is spontaneous as written. So we're going to work a few of these and learn a shorthand notation for ourselves in our next few videos. So until then, this is signing off.